Let's go ahead and jump right into it. If you haven't already, go ahead and create an account or log in into your GitHub account because we'll be using that today. In the meantime, while you are doing that, I'm going to go into a presentation. And this is a presentation, again, to help aid us into the transition of Rails. Rails does a lot of things for us, so I'm just going to break one of those things down, and we'll be going over this here. So yesterday we talked briefly about CRUD, which is essentially what you can do in almost every functional web application or any application at all. So CRUD stands for create, re-update, destroy, or sometimes you call it as delete. And essentially, almost every applications you would make is this, if it's a functional application, like if you are able to do multiple things with it, then you would have some sort of a CRUD actions. And that's with Facebook, YouTube, all of that. The other thing is if you have a static application, if it's just only pages for information, that's still technically doing a read CRUD action, but you're not doing all of the CRUD actions with that. So essentially, you'll be doing either all of them or just some of them in your web applications. You're able to see this presentation, right? Oh, okay. Yep. Awesome. So that goes into this new topic called HTTP and HTTP protocols. So HTTP stands for Hypertext Transfer Protocol, and essentially is a big word for a simple definition, is the way the browser communicates with each other. So it's just data communication between browsers. And it's developed by CERN, and it's actually pretty recent. It's around 1991, so very brand new for the technological field. And HTTP is something you actually use almost every single day without you even realizing it. And I'll kind of show you what that is. So when you are talking about HTTP, you're actually talking about the HTTP verbs, the things that you can do inside of a web app. And essentially, it just boils down to the CRUD actions, right? So CRUD actions would create, read, update, and destroy, each have their own designated HTTP verb. So this is the direct translation for HTTP for the specific CRUD action. So when we want to create something, it'll be a post request. If we want to read something, it'll be a get request. If we want to update something, you can do put or patch. The most common one is put because it's 3 letters compared to 5. And then the last one is destroy if you want to delete something in the browser. So those are the direct correlation when you're dealing with HTTP and HTTP requests, is that they're doing CRUD actions in a sense. And there's a lot more other verbs out there for HTTP, but these are the most common ones you'll be looking at. So with each of these verbs, again, they correspond to CRUD actions. They actually require you to pass something with it, and sometimes it'll return something back. So the default HTTP request is actually a GET request. And this is by default, even if it's not specified, the GET request is always the default action. And essentially, it will either return an HTML, which is a web page, XML, or JSON, which is just objects. And that's the same thing of like if you are going to, let's say, Google, for example, right? This is technically doing a GET request. It returns an HTML page. So we're doing a GET request with that. What a post request is that we are creating something. We are posting some sort of information into their database. And when you are doing a post, it actually requires some parameters. For example, if you are posting a Twitter tweet, for example, then the parameters that might be in that tweet would be the actual tweet itself and the author and the title, things like that. Those would be the parameters a post would need. Because when you are posting something, you actually need items of what you're actually adding it on to. And this kind of ties into what we learned yesterday with SQL. When we are having to insert a record inside of our database, we need fields, right? We need actual values for that to work. Or else how do we know what we're posting? Or else it will be an empty string. So that's the create portion of it. Put and patch, it needs two parameters. The first one is the ID, so you know which one you are updating, or else you'll end up updating everything, right? That's not the ethical thing to do if you're updating everything. So you need to have a unique identifier to show you which thing that you are updating, and then what you want it to be changed to. So those are the parameters when you're using put and patch. And then lastly is the delete, the destroy CRUD action. And again, this is very similar to what we have up top with update, is that you need to require an ID or else you'll end up deleting all the records or all the data in the background. So you do need an ID with that. So with these HTTP verbs, that is essentially what we'll be sending through our Rails applications when we want to do a certain CRUD actions through the web. So if we want to have a page up, if there's a page for the about page, like the home page, that will be a GET request, right? And then inside of like the post page, when you are submitting new data, that might be a post request when you are hitting the submit button. And that might be a put or post, depending on if it's an update form or a create form. And then finally is the delete. If you are deleting, that will be a specific HTTP verb as well. And another thing that all of these things will come back with, what it will always return, is some sort of a status code, right? And these are status codes, depending on what number they are, they mean different things. So you often will see this occasionally when you're working with web pages. So anything in the 200 range, that's a successful request. That means that it is successfully through, there's no problems there. A 300 is a redirection. It will take you to somewhere else, maybe to another page. Usually it will be a 300 and then a 200 afterwards. Because typically after you go to the redirect, it will take you to another page itself. And then this is a little bit more important, where we have errors, because you'll encounter errors regardless, right? And there are two types of errors you'll be seeing. The first error is the client error, and the other one is the server error. So client and server error. And you probably already seen some of this. Everyone saw 404 pages before, right? I think Wendy's have a good one. I don't know. Yeah, these are all 404 pages. Websites have them. They make a really good placeholder to tell you that there's not a page for you with that specific URL. So that is considered a client error. And let me break down these terms a little bit more with client and server here. So the difference between client side and server side, we'll be using these terms a lot, is that essentially the client side, that is everything the user sees and interacts with. And that is considered the front end side. So the client side, you can think about it as the front end side, anything that the user interacts with or looks at. The server side is any background processes to make the things on the client side function, right? Or something in the backend side. So that you can think of server side as backend, client side as front end. So if you're taking a look at the status code, this client error here, that means that you have something going on in your front end. And this server side error, that means you have something going wrong in your back end. So that will actually help you kind of narrow down your search of where your errors are. Because later on, when we jump into Rails next week, you're not going to be dealing with one or two files. You'll be dealing with a whole system of files and folders. So it's good to pinpoint where those errors are, and then you can pinpoint where exactly they are in the files. Now, there's a bunch of ways you can make requests. There's a tool that you can use that's built into your command line terminal, which is called curl. And there's no additional installation or anything. It comes fresh out of the box. So you can use curl as your own instant way to make requests, and you just need to pass in the parameters and all that. The other tools you can use is called either Ajax, Fetch, or Axios. These are tools that we'll be using a little bit later, and it allows us to make requests through our front end and connects it to our back end sometimes too. The one we'll be using is Axios, and that will have our front end, which is the React side, communicate to our back end, which is our Rails side. So I can send a GET request from my React side to my Rails side, and that will give me the right information for me to display a web page, for example. So that is the other way you can make requests. And the last way you can make requests is that you can do it through your browser. Like I just showed you, we did a GET request anytime that we go into a specific web page. That's technically doing a GET request, right? The other thing is that what about those other CRUD actions? Well, that really does depend. Like, for example, for Facebook, you can't really make a Facebook post unless you're logged in, right? So you're able to create posts, update posts, and delete posts as long as you're a user and logged in with that. So you may be limited depending on the use case of each application. But by default, the most one that you'll be encountering is the read request. So that's essentially it. The main point is to know the difference between server side and client side, and also know that these terms here correspond to CRUD actions. So post, get, put, and delete. So any questions about that, about HTTP protocols? And we'll touch base on this again when we hop into Rails. Awesome. This presentation will be available to you inside of Neo after I release the item here. Okay, so now let's go into the fun part for today. So Get is a really exciting topic because it will be something you'll be using almost every day going forward and throughout your whole developing career. And I just want to talk a little bit about it, just to break down key terms and a lot of vocab here and there, just so you know what I'm talking about when I talk about Get. So essentially, there's Get and GitHub. So we'll go into Get first, and essentially what it is a version control system. What it does is it's a piece of technology that we downloaded at the beginning of class, and it helps us to store project files, and it also helps us to collaborate with other people, right? So that's the reason why we're using Get. It allows us to store all of our project files in a safe manner, and also helps us collaborate with other people. And it was developed by this company here back in 2005, so it was relatively a new piece of technology. With Get, there's something called GitHub, and Get and GitHub are actually two different things. Get is the technology, and GitHub is actually a service that uses Get. So those are two different things. When we're talking about Get and GitHub, we're talking about two different items there. And with GitHub, we are actually hosting all of our project files inside of GitHub itself. So that is where all of our project files, where we saved it, that will be where it's going to be located. And it's also a way for us to look at other people's projects, as well as a way for us to collaborate with others too. So that is the difference between Get and GitHub. There's other GitHub alternatives. There's GitLab, there's also Bitbucket, and other technologies that other companies use as well. So usually you won't be using GitHub, but you're for sure going to be using Get. That's the main bare bones of the technology. And recently, GitHub, well, I meant recently as in 2 years ago, GitHub actually got bought from Microsoft. Does anyone know how much Microsoft bought GitHub from? Well, let's take a look. So back in 2015, GitHub was thought to be a $2 billion company, which is pretty big, right? That's a pretty big company. But in 2018, Microsoft actually bought it for $7.5 billion. So that's almost close to 4 times the amount of what it was 3 years ago when it was projected. So it's a very useful project, and it gained a lot of popularity and stuff. So that's why we're using GitHub. It's a very popular technology. A lot of people uses it. It's a little bit more popular than GitHub and Bitbucket. So now let's jump into more about Git and other key terms. We actually already did this the first day of class. We did something on computer setup. You may or may not remember it. We did a Brew Install Git. So Brew Install Git downloads this Git version control system into our system. So now if we're able to use Git inside of our terminal as well as inside of our project. And if you want to download Git inside of your other machines, for Mac, it's like this, but for other systems, you might have to look it up. There's a download or maybe a zip file for that. The other thing that we did is that we also did this command here, right? This command where you put your email here. You have to press enter a lot until you see like a weird looking symbol at the bottom. You may or may not remember that. But essentially what that code did on line 17 actually created us a SSH. And essentially what a SSH is a secure connection from your own machine, your own local machine, which is what you're using right now, to your GitHub account, right? So this account here that you create on GitHub, we are going to connect it to our own machine here by using the SSH. And that is a much more secure connection. And also, you don't need to type in your username and password every single time that you're using the tool. So that's a great way that you would be doing that. One more keyword, and then we'll go ahead and go into some configurations that we need to do. And that is the keyword of repository. Repo for short. I forgot to type that in here. So sometimes you hear it called repository, or you will hear it be called repos. So essentially what a repo is that if you have Git inside of your project and it's turned on, that will hold all of your project files and version. So your repo is actually holding all of your file versions inside of that little file that we'll take a look at. Essentially, all of your projects from here on out will be its own repo. So every time that you do a project, you would have it be also a repo, and that way you can also track your project files and versions. Now, there are some drawbacks to this, and some things that you shouldn't do is that you should never make a system directory a repo. That means that your desktop document downloads, oh, that all starts with a D, pictures, any of those system directories, they should never be repos because there's no need for them. And sometimes they might have some items that you don't want to be pushed up to GitHub, because GitHub is a public space and you might not want everything on there. The other thing is you shouldn't create a repo inside of another repo. It actually won't work like the way you think it would. So when you are creating a repo, make sure that it's inside of its own repo or its own directory, so you don't have it inside of each other. And if you accidentally do, I'll show you what file to delete to undo that command. So just note that every project is going to be a repo. That way we can keep track of all of our code and versions. So any questions about that? Okay, let's go ahead and go into configurations then. So everyone already installed Brew and also create a SSH, which is awesome. That really helps us to help set up. The other thing is that you should already be logged into here. So first thing, we need to grab our SSH key. So go ahead and hop into your Slack and copy this command and paste it inside of your terminal. And it doesn't matter which directory you're in. It just matters if you copy and paste it correctly. And if it says there's no ID.rsa file, that means that you may have to do something else because your computer isn't fully configured with Git. So it shouldn't give you anything at all if it's successful.
Okay.
Does anyone have that error where it says no file found?
Yeah, I got that error.
Okay. Since you have that error, go ahead and run this command, but be sure to put your email there. And then also keep on pressing enter, even if it asks for a passphrase and all that. So after that, just keep on pressing enter until you see like a weird symbol there. And then do this command again. So the SSH is a unique fingerprint, a computer fingerprint that each machine has. So we'll be using that instead of typing our information like our username and password for GitHub when we do interact with GitHub, which is awesome.
So what did that do exactly? Did that just copy all the fingerprint to our clipboard?
Correct. So PB copy is copying into your clipboard, and we're copying this whole content of this file inside of our clipboard.
Okay, so if I paste this, then I can kind of see what it is.
Yeah, we're actually going to paste inside of our settings.
So mine came back and said terminating app due to uncaught exception, and then there's just like a bunch of stuff.
When you did PB copy.
Yeah.
Interesting.
Is there a space in between the / and the .ssh?
Yes.
Okay.
Oh, wait a minute. No, there's no space right here. Is this where you're talking about?
Yeah. Sorry, in between those.
Yeah, no, there's no space here, but there is a space between.
Okay. And it worked now.
Awesome.
That was my problem.
Yeah, it's super picky. So let's go ahead and go into GitHub and then go into your settings. And then update your settings here if you haven't already. It's good to have a profile picture and your email and a quick bio if you want it as well. But the main part where we want to be is SSH and GPG keys. That's where we want to be. So that SSH and GPG keys. Again, I went to this little caret up here, settings. And inside of settings, there's a tab on the side that says SSH and GPG keys. We're not going to use GPG keys. We're actually using SSH, which is what we just copied. So once you're here at this page, there shouldn't be any of these items here. It should be blank for you. If you do, it's okay. It's okay to create a new one, but it's okay also if you don't have any of this. So go ahead and press new SSH key, and then paste what you just copied like that. Not the command, the actual thing where it copies your SSH. So it should look something like this with your email at the end and a bunch of jargon. And then title this what you would call your computer. Like if you have multiple computers, you might have to call it something else. Like if you have, I usually just call it Henry's MacBook. But if you have multiple MacBooks, you can just be more specific, like Henry's MacBook Pro or Air, things like that. So you only have to do this once per computer.
Sorry, I'm a step behind. I got lost for a moment. Why are we pasting in the key? Where did you get that from?
So if you go back here, are you on this page?
Yes. And then I clicked on that.
this is where you would paste it here. So command.
Oh, that. Okay, gotcha.
Yeah, and it should show up here.
But sorry, where did you get the key to begin with? I missed that piece.
Is what this command does for you.
Oh, it's just copy. Oh, gotcha. Okay, thanks.
Henry, do we
Yes.
need the title of this? Does it have to match the actual computer name, or can we just type in an alias that describes so we know which computer it is?
Yeah, just describe it more than anything. Because I have multiple computers, laptops, and a Windows machine, so it's a good way to distinguish between your computers. And
Thank
then
you.
go ahead and press Add once you have both of those fields. And it should look like this. So on those other machines, if you have Git already installed and configured, you can also add the SSH for those machines too. That way you can share code between your computers, which is awesome. So that's the first configuration that we'll be doing, is to add the SSH key inside of our GitHub. Okay. And I'll show you around GitHub if you're new to GitHub in a bit. So let's continue on with our configuration. And for this part, I am going to configure some predefined Git configurations. So go ahead and type in what you see on the screen, but for these next two items, it will be in your case, right? So don't put what you see here, but it will be what your name is. So it'll be git config -- global user.name, and inside of the string, type in your full name. Just your first and last, not your last name. So it'll be like that. And then go ahead and press enter.
All lowercase.
Doesn't matter. You can do uppercase or capitalize, whatever works for you.
So first name space last name inside of the double quotes.
Yep. Make sure you're ending your quotes. And there is a space between here. But there's no space between these two dashes.
So what is this doing exactly? Did we just create us a username? Is that what we're doing?
So we're just telling our machine, because it should be a fresh machine without Get being configured. And we're just telling Get that our name is the name that we specified inside of these posts.
Okay.
Okay.
I guess we could run that as many times as we want and keep changing it, couldn't we?
Yes. So the next one is go ahead and press up if you already press entered on this command. And we are going to change it a bit. It will be user.email. And inside of a string here, it will be your email with the item here. So be sure to have your email. Preferably, it should be the one matching the one you sign up with GitHub. If you
Henry, were we supposed to do this with the username and the email, or just the email?
the name and the email itself.
Okay.
So two different ones.
Git config global user.email.
And put your email, not what you see on the screen.
Do you guys have a lecture on like all of these commands that we've been using to install all of this? Just in case I want to do it on like my Windows machine or.
Windows is a little bit different. It actually won't be using these same commands.
Even if I have a Unix.
Yeah, if it's a Unix or a MacBook, then yeah, it will be the same command. But yeah, it's inside of your day one lecture.
Okay.
And
Cool,
computer
cool.
setup.
Cool.
Go ahead and press enter on this if you haven't already.
Uh-oh. If we went, I accidentally used double quotes. Would that?
That's fine.
Okay.
Yeah, as long as you're ending the double quotes, that should be good. Okay, and then this should take you to a next line. And I already pasted this out but essentially is the same get config command. But in this case, we are specifying what technology we're using when we're dealing with get stuff inside of the terminal, and that is by default Vim. So Vim, there's a connection there. There we go. It's one word. So Vim is a predefined text editor that comes within your terminal. So when we are resolving our conflicts or resolving anything related to Get, we'll be using Vim instead of the default tool that they have. And go ahead and press enter on that if you haven't already. Okay, 2 more steps. The second to last step is that we need to create a file inside of our root directory. So go ahead and do a touch ~/.getignore, and it will be no spaces between the slash and the dot there. And if it says you already have a getignore file, that's awesome. We'll be using that one. But if it doesn't, it should take you to the next line. I'll go into depth what a repository getignore is, but this is what a global getignore is. This is what we should ignore and never push up to GitHub anything that we put inside of this file here. So it's a special file inside of Git that let Git know to ignore and not push this up into GitHub. So once you created that file, we are going to open that file. You can do open or you can do code, whatever works. Either of them works. And then put these 2 items inside of that file and then press save. So with the Mac, it comes with a dsor file. It's a hidden file that always shows up when we're creating projects and stuff. And we just want to hide that from Git because we don't want to put useless information that doesn't pertain to our application. So that's one of the files. And also VS Code does a similar thing. I'm pretty sure Atom and Sublime does too. And we're not pushing those specific files up. And be sure you have the casing matching here as well. So it should be capital here.
Hey, Henry, how do we open the gitignore in VS Code?
You would just do code.
I did that, but it's not opening up in, okay, let me take a look. Thank you.
Or you can do open, that works as well. So VS Code and the DS store. Those are just informational files that the computer and VS Code needs, but we don't need them when we are coding. And then save that if you haven't already. Okay, let's do this last step. And I'll slack it out here for you all. Go ahead and go into your terminal. And after you type all this in and save it, you would then go here and then run the command I just sent out. So this will exclude all of the files that are in that particular gitignore file.
Henry, my gitignore file's not opening up.
Even if you do open?
Even I tried open, I tried code dot, and I just tried searching for it in Finder.
It's a hidden file, so you wouldn't be able to. And you already created it, so you did.
I had the same issue. Instead of code dot, try code, and then the ~/.getignore. It worked for me when I did that.
Did it? Okay.
Mm-hmm.
I think code dot just opens the directory that you're in. So, and since it's a hidden file, you wouldn't see it doing code dot.
Yeah, I got it. Thank you.
Awesome.
So Henry, what am I supposed to write in the code again?
It is these two items here, and it's
Thank
also in Slack, so you can copy and paste it too.
Can you go back to the git config?
That command here. Yep.
Okay, thank you.
So after you're done with this, do this command here. So you only have to do these steps, these configuration steps once per machine.
So even if like we ever create a new GitHub account with like new emails and stuff, we still wouldn't have to do it if it's on this machine.
Yeah. You can use the different GitHub account, but you can still use the same Git configurations.
Okay.
Okay. Let's go ahead and prep for our next part. And I already slacked out the nodes, so that's up there inside of Slack. I am going to go ahead and go into our follow along, and the best thing about Git is to practice it. It's one of those things that you'll be doing every single day, and it's hard at first, but then it'll start to get easier once you practice it. The other thing is that Git follows a specific pattern. If you keep doing the same pattern well, then you don't run into any problems. But if you actually like change or go out of the flow, then you might be going into some issues there. So go ahead and go into your desktop and then cd into your project directory. So desktop project directory. And let's make a new folder. And with this new folder, I'm going to call it Get Practice. And I'll also be calling it Summer 20. You don't have to do it this part. I just don't want a bunch of Get Practices and not know the difference between them. So you can just still call it Get Practice. So after you create that, go ahead and cd into your Get Practice folder. And if I open this, it's an empty file, right? Unless you have that setting turned on, you can see hidden files as well. Also, you can do ls, and you can also see that there's nothing inside of this folder. So right now, as is, when you create a folder or when you create a directory, it's not a Git repo. You actually have to initialize it into a Git repo. And to do that is with this command here. It's called git init. Git init. So once you're inside of your Git practice, you would then do this command here. Essentially, you'll be doing this command once per project. So git init. And what this does is it initializes the empty GitHub repository in the particular folder you're in. So if you take a look at it now, you still won't be seeing this because it's a hidden file. So anything that starts with a dot is technically a hidden file within MacBook restrictions. So to actually see this file, you have to do ls-a. ls-a. So what ls-a is, it shows you all of the files even if it's hidden. So if you just do it like an ls, it still won't show it. You have to do an ls-a to see all of that. So here, this is what is holding all of your code versions is inside of this file here. So let's say that we want to delete this get because we may have did it inside of our desktop or in our project directory. What you would do is you would just delete that file, and that's no longer a repository. So you can just do like a rm.get, and that will remove it, or rm-rf-get. Then you can have that folder be no longer a repository. Don't do this. This is just for example. But if you do want it, then you would just need to do a getnet in a particular folder, and it will have this hidden file here. Okay. That little hidden file, that will hold a bunch of code for us. So let's also have some files for us to work with. So I am going to create 2 more files. It's going to be called main.rb as well as password.text. Is a text file. I'll zoom out just a bit so it doesn't overflow as much. So we're creating 2 files here, nothing too crazy. So now let me show you one of the Git commands you'll be using a lot. And I'm going to do Command R just to clear up the console. So this next Git command is called get status. It actually shows you where you are inside of this process in Git. So we do a get status, it will tell you some information about where you are inside of the process. So it says on master branch, we'll talk about branches a little bit later on. No commits yet, we'll talk about that too. And it also says there's 2 untracked files here. So untracked files are what Git doesn't know about yet. And then there's nothing added or to be committed there. So to have Git to know which file to know which file you want to include, you have to do a get add, and then the file name or the directory. But we also have this file here, and occasionally this is what you'll be dealing with. Is that let me go ahead and open this up into VS Code.
Henry, what is a GPG key versus the secure shell?
We're just using SSH. That's the unique identifier. GPG is something else that we're not using.
Okay.
Yep. So now we have 2 files here, and that's pretty typical for a project. One is your main project file, like that's where your Ruby code will be. The other one is going to be some sensitive information, such as if you need to have a password to use other APIs, for example. So let's say my secret password, I'm just gonna put my password, is equal to this here. That might be relevant inside of my project, but it's not good to push this up into GitHub because, again, GitHub is a public place. I can actually see other people's repositories if they push it up. So something like this, something like the password.txt file, you need to have it be hidden from Git, right? Even though we are using it, we don't want other people to use it online. And there's actually bots inside of GitHub that looks for API keys and your credit card info, your emails, things like that, all through Git, right? So it's not good to have personal information or anything that requires private eyes, right? So it's good for you to hide these type of files. And to do that, whoa, I'm just going to go here, there we go. To do that inside of your terminal, we will actually be creating a gitignore here. So gitignore inside of this level is actually going to ignore it inside of this repository. So it's a repository ignoring. The other one that we created earlier, that is what we did globally. So regardless of where we are, we're regarding those files and that throughout the whole system. This one, it only pertains to our project here. But should show up right here. That's weird.
Mine showed up.
I'm just gonna reopen mine. There we go. Might not be doing it fast enough. So yeah, it should be a file here like that.
What does the U stand for, right to the right of those?
right here. It means
Yeah.
untracked.
Oh, okay.
Yeah. That means you created a file or there's some change, but Get doesn't know about those changes yet. That's what untracked means. So inside of your Get ignore, it's pretty self-explanatory. You would put items, either folders or files that you want to have Get to be ignored. So in our case, it would be password.text. And it's the exact same name and casing as what your file is here. And if it's inside of a folder, you have to navigate into that folder. So if you have like a folder called like save files, it'll be /save files / whatever those files are. Let me give you examples. So I'm going to right click new folder. I'm going to say secret password here. Yes.
Henry?
Yes.
So right now it was already uploading password.txt until you put that in there.
No, not yet, because we
Okay.
didn't track it yet.
Oh, okay, gotcha. But it would have done it. That's what the untracked means.
Yes.
That's what, because then it like deletes the U. Okay, got it.
I don't seem to be able to find the Git ignore file.
Inside of your editor.
Correct.
And you did do touch the Git ignore like this.
I did not. That's what I meant. Well, I thought I did that earlier. Did we do that earlier?
Yeah, we did, but it was inside of the root directory, not this
Got it. Okay. Okay.
Yeah.
Thank you.
So you would need to do that also inside of your project as well. So here, if we want to ignore a folder, it will just be / and then the folder name. Or you can navigate even further down into it with that, if there's items in the folder you want to ignore. So as you can see here, there's no longer a U inside of VS Code. If you are using VS Code, there's no longer a U right next to it. It's actually grayed out. That means that it's not being tracked at all. So it's actually being ignored. So these gray items, those are the ignored items. But these ones are untracked items that we have that we still need Get to know about. But Get doesn't know about it yet. So be sure to save both of these files, right? Especially the Get ignore, and double check, right? Double check that your stuff is grayed out so your information is safe. Because you don't want to put your password or credit card info online. So now let's do Get status again to see where we are in the process. So now the only untracked files that are not that Get doesn't know about yet is the Get ignore and the main RB. Notice here there's no password folder and there's also no password file as well. And that's what we actually want. Is that these are the untracked files that Get recognizes. So let's have
it
Get
has
recognize
Git
that.
ignore as untracked even though password and secret password are saved in it.
Yeah, those are mostly ignored. Yep.
Right, but Git ignores, or what was it? That's also okay. That's also untracked, I guess.
Yeah, because Git ignore is technically a file itself.
Mhm.
You're not ignoring the Git ignore.
Right, gotcha. Okay.
So let's go ahead and track these files and track these changes. And we'll just have the suggestions here. So technically you can do get add and then the file name, like main.rb, and also the folder name and all that. But again, it works, but then what if you're dealing with a bunch of files and folders, right? That's actually not a good way to do it. Better way to do it is space dot. What get space dot means, it includes everything that's untracked. So it's very similar when we do code space dot, that opens everything inside of our directory into VS Code. This one adds all of the untracked files to be tracked. So get space dot, and there is a space between them. You'll get a weird error if you don't have it. So now it doesn't do anything once you do that, but if now you run a get status, you can see now it's green, right? It says these are changes that needs to be committed. So changes that needs to be committed here. So it went from untracked files to something that Git knows about, and now waiting for you to label those changes.
So Henry, so does that mean if we go back into our Git account online, would that be in a repository?
Not yet.
Okay, we're going that way though.
Yeah, all this is still happening inside of that hidden file that we have here. So it's all happening in this hidden file here. It's not until we push this up into GitHub, that's where things will be inside of GitHub. That's a good question. So now let's go ahead and let's take a look at our next step here. So the next step for our flow is after we added all the track files, we need to have it be committed. So essentially what a commit is just a label of what you just do. These are certain key points during your version history. So let me explain this a little bit better. I'm going to see if I can annotate. Can you see this line I have here? It's a red line kind of.
Yeah, we can see it.
Okay. Let's see if I can make it a little bit thicker. Ooh, there's actually a line, so you don't have to see my ugly lines. Cool. Okay, so let's pretend that this is your code and what you're doing when you're coding, right? It's a linear line. At certain points, you would want to go ahead and save your work inside of Git. Those will be these specific points here. Like certain times you want to save your points here. So essentially, when you get to a spot inside of your code where you're good to update your Git, then you would need to add and commit it. And this is what represents a commit in a sense, is that when you're adding committing, at this point in time, you're labeling what you just did in this past previous timeline here. And then after that, you can continue coding and coding until you hit another place where it's good to stop and save your work. You would do another add and commit. And again, this is a label of what you just did between this commit and this commit. So that is essentially what you'll be doing in between your projects, is that you'll be adding and committing while you're coding. So that's what a commit is at this point, is that we are going to label what we just did so far in this project. So far,
if you do a commit though and there's no repo, then what's it really doing?
it only works in repos. You can't do it outside of a repo.
Oh, okay.
Yep.
Okay.
So let's go ahead and label what we just did. And it's good to be descriptive when you are doing this step. So it's going to be get commit space -m. And after the M, it will be a single or double quotes. It's really up to you. And inside of these double quotes, it will explain what you just did, right? And I would keep it short. I would keep it like 50 characters short. And I would also, it's good practice to have any features that you did will be in here, or anything that you did that will be past tense, right? So it will be past tense stuff. It would say a good message would be created files, right? A bad commit message would be like, I'm going to finish my homework. That's not really a good thing to write. So it would be explaining what you just did in your previous work timeline. So it'll be like a message, or it'll be what features that you finished. So those are good commit messages. And be sure that you are closing out your quotes if you haven't already.
Do we need to do that same thing on our?
Yes. And it should give you this output here. It will say 2 files are changed, and there's 2 lines of code, and these are the 2 files that are created. So we just labeled what we just did. So first the flow was to create a repository. You only had to do that once per project. And as we're coding, if we are at a good stopping point, we need to add our files for it to be tracked. And then we need to also commit it for it to be labeled. So it needs to be tracked and labeled. So that's what adding and committing does. It tracks our stuff with add, and commit labels what we just did. So now if you do a get status, we'll be doing get status a lot. It'll then say there's you're on the master branch and there's nothing to commit. You're on a working clean tree. So there's actually no new changes that get picked up so far. And that's what you should be seeing for the most part when you have a successful commit. You can also see a list of all your commits with this get log command. So get log here. This logs out all of your get commands and all of your messages, as well as who did it, right? So this could easily track, if you're working with others, who created the GitHub commit. And that's what the items that we did inside of our configurations with your name and email here. It also tells you when, and this is a timestamp, and what is the commit message there. But if you really don't care about that, there's this other command called get log -- one line. That will just give you a one-liner of all of the commits happening so far. As you can see here, each commit has their own unique identifier. It's just a combination of strings and numbers, right? It shows you what a commit is. This one is just a shortening of that long message here. Okay. So I am going to slack out this code and go ahead and paste this inside of main.rb. Because I don't want to dive too much into Ruby. I more want to focus mainly on Git. So go ahead and copy this and paste this inside of your main.rb. So this is just a simple Ruby program where it first runs menu. And it either, if you press 2, it exit, or you can press a get command. So if it does a conditional, depending on what the user choice is. With that user choice, if they press 2, it will exit. If they put anything else, then it will actually give you invalid choice and loop back to the menu again. But if they press 1, you would then enter a get command, and then it will go into this here, this method here. With that get command, it will actually give you a similar to the man pages. So information page inside of your get. So that's all this program is. It's just a manual pages for get commands. So we do a get status right now. You can see that we modified the particular file of main.rb. Those are changes that get picked up that hasn't been tracked or it hasn't been labeled yet. So that's what this message means here. And that's true. We did add a bunch of code that Get doesn't know about. And then you should see an M here, which means modified. So that is a file that is modified from the last commit. So VS Code is really nice for you because it labels things for you. Okay, let's go ahead and leave off right there, and we'll go into our first break. Come back at 7:10. Jump back into it. So where we left off is that we just talked about what a commit is. Is that a commit is one of those places where when we need to stop and have our files tracked, we also need to label what we did thus far. So that is what a commit is. So here, before our break, we went to our main.rb file and we added some code here. This is just simulating that you are coding and you're at a good point to save your work, right? So this is a good point to save your work and put it into your Git repo. So the first thing you should do is you should test this out to make sure it works, because you shouldn't be pushing broken code into your system, right? So let's test this out. So I'll do Ruby main.rb. I'll do it so you don't have to. We'll see that one works, and get command of commit. And that is
sorry, related to that, would you ever do that just to like share code? Like, hey, I'm halfway done with this, I pushed it to Git, someone check it out, or would you share it? Like, is Git more for finalized things?
Finalized work? It'll be more beneficial if it's finalized, but if you do have a broken code, or if you want someone to look at this for a second pair of eyes, you could do it like this as well. But there's actually a way to use Git, and I'll show you that shortly.
Okay.
Yep. So yeah, so it looks like everything is up and running, and that's a good thing. So if it is at a good point for us to stop, let's go ahead and follow that process. So save your work. Sometimes it doesn't track files that aren't saved, so auto save should be on if you don't have it already. The other thing is that we need to go ahead and have it tracked and also label what we just did. So it'll be get add space dot. That is to have our items tracked, and then get commit what we just did. We'll just say build program, nothing too crazy. So we'll be doing a get add and commit after we paste all that code there. And essentially inside of our coding timeline, we're just adding another dot, right? So inside of this timeline, we're coding and coding. And our first dot was when we created our files. So that's our first dot here during that specific time. And then now our dot is when we just created this folder here, or this program here. So we just created two more dots, or 2 dots in total, I mean. Okay. So what if you want to, let's say I messed up on my commit, or I want to do commit another way. Like instead of saying build program, I actually want to change it. There's one way you can do that, and that's with Vim. So I'll do this so you don't have to, because it's a little bit confusing and very intimidating at first. So occasionally you'll be thrown into Vim. So if I do get commit dash amend, what is, oh, still thinks I'm drawing, there we go. So if I do get commit dash dash amend, I'm able to change my original commit message if I want to. You don't have to run this. I'll run this so you can see what's going on. So what this does, it'll actually take you into this window here. This actually takes you into Vim. You can see it here, right here, if you can see that. So Vim is a text editor built into your items. And if you press whatever on your keyboard, nothing will actually work, right? That's the first scary thing when you first go into Vim. So the most important thing that you know is that Vim has 3 modes. The first mode is the command mode. And that's what this mode is. There's also the insert mode where you're able to actually type stuff in, and the visual mode where you can look at everything. So if you want to switch between modes, it's with your keyboard, right? So if you press I here, you can see here towards the bottom, it says insert. You're now in the insert mode. That's where you want to be at this particular level. Then you're able to move your cursor and you're able to type. Let's say I want to build a Get program to be more specific, right? So there's no saving or anything inside of Vim. It's a little bit different. Your mouse doesn't work, so there's a lot of hotkeys you have to use. So first, you need to go out of insert mode, because everything else that I type, that is technically still typing. I don't want that. So to get out of your insert mode, you would just hit the escape key. That's the key on top of your one, and it might be in your toolbar if you have those touch toolbars. So it should be like this. This would take you into the command mode. And then when you want to save and quit this message, you would do a shift colon, which is just a regular colon. So shift colon, write and quit. So this is how you would save and get out of Vim. So be sure you know how to do that. So first you need to escape to make sure you're in the command mode, and then shift colon WQ, or else you'll end up like this guy. I've been using Vim for about 2 years now, mostly because I can't figure out how to exit it. So be sure you know that exact combination. So escape, shift colon WQ.
What does that stand for?
Write and quit.
Write and quit? Yeah,
Yes.
okay.
And it should take you like this. So just note that you know how to get out of Vim when you do that. Okay. Awesome. So with that flow that we did, so occasionally you would do a get init, and then a get add, and a commit at certain points inside of your projects. Just get used to doing that. A good place for you to see where that is in your lecture notes or in this video, or if you go into the DPL sheets, go to get flows. Get flows. And occasionally these are the steps that you would take for each of your projects, right? So the first time when you are creating a repo, you would do a get init. And then when you are at a good point, you would do an add and commit, label what you just did. Afterwards, you would do this to push it up into GitHub. And we'll be doing that next. And then every time after that, you would just do these steps here. So add and commit, and then push it to origin master. So that is inside of your DPL sheets there. So there's a certain flow that you would do every single time that you're doing this. So let's go ahead and push this up to GitHub, because this is actually a good spot for us to do that. Because now everything is still in our local machine. It's still inside of this file here, this little Git file here. In actuality, I want it to be in a more public place, because either you're submitting an assignment or sharing a project with someone, it should be in some sort of a repo service provider like GitHub here. So what you do is you will go into GitHub, and you can press new repo here, or you can do new repo up here. I like to do it up here, but it's really up to you. So go ahead and press a new repo. You can change the owners if you're a part of a company and all that. Like I have DevPoint Labs and Studios, but I'm just mainly using my own. And you would label your repo name here, right? So this repo is actually a repo inside of GitHub. This is different than the repo that we just created here. But we need to connect both of those together. So with your repo name here is typically a good practice to label it what you labeled your project. So I'm going to label mine Get Practice. And in your case, you can just label it Get Practice. I'm going to do Summer 20 because I have more than one Get Practice in my profile. And this is a unique repository name to your account. So there should be a unique name for each one of your repositories. You can describe what it is if you want to as well, and also add in a README, but that's mostly for documentation, and documentation is a whole nother topic, so we'll probably won't be doing that today. So we'll leave those two blank. The next option is if you want to have it private or public. And until recently, I think back in 2019, all of GitHub repos are now private for free. You would have to pay for this feature, but now it's actually a free feature for us to use. I think it's a private up until if you're sharing it with like a whole bunch of people, then you might have to pay with their services there. But for now, you can do public or private. I will do it public, so anyone can be able to see it. But with private, only a few people you choose are able to see it. So it really depends on the project. but in most cases, you would want it to be public. And all these will be the same default settings here. So go ahead and press enter or create repo here. And it will take you here. So it will tell you how to initially import your repository into GitHub, but we actually already did some of these steps. So for this next step, make sure that this is highlighted SSH. So make sure this is highlighted SSH. HTTPS is something that will require for you to upload your password every single time. We actually don't want that. We want the SSH because we set it up inside of our GitHub account, and that is what we'll be using to connect both of our machine into this particular GitHub here. So go ahead and copy this link here for SSH. It should look like this. It should start with get, not HTTP. And also, you can press this. That could also copy it too. So that will copy it to your clipboard.
Henry, mine doesn't have the quick setup under code. Where can I go find that?
What do you mean?
So when I have a similar looking screen, but mine just says readme.md and it has the readme file, but it doesn't have this quick setup.
Oh, like this quick setup here? In your case, do you see a green button here?
Yes.
So if you click on that green button, there would be a place for you to click on SSH.
Oh, it says use SSH or open in desktop or download zip.
Yep, you would do use SSH, okay. And then you would it will give you a URL. You would copy that URL.
Okay, thank you.
I think you may have created a README file.
A what?
A README file, but that's fine. So now let's go ahead and copy this command, and we're actually going to connect both our repo inside of our local machine to the repo here inside of GitHub. Because these are two separate ones, until we do this step, they will be connected. So this step is get remote, add origin, and then you would paste what you have there. So be sure to paste what you have after the origin. So what a remote is essentially what we call this GitHub repo here. It's a remote. So it knows that this particular remote, this particular repo is connected here locally inside of our machine. And you can take a look at all the repos that it's connected to here. If you do get repo-v, these are all the repos connected to this local repository. So origin, you have two of them. The first one is pushing. The second one is fetching. So there's push and fetch. Pushing is where you are putting stuff onto GitHub. That's what pushing is. So you want it to be pushed into GitHub. Fetching or pulling, sometimes it's called pulling, that is when you're grabbing code from GitHub into your own local machine. So that's get and push and fetch. So now that we have that step connected, we'll do a get status, and it should be on master branch, nothing to commit. And then with that, we now will be pushing this initially to GitHub. So it will be get push, the name of our remote that we want to push this to, which is this one right here, and then the branch where you are wanting to push it in. And I'll again talk about branches afterwards. And if this is your first time pushing, it'll ask, do you really want to push? Go ahead and press yes or enter or whatever the message is. So this is the next step.
So when we go get push origin, what is it that we type after that?
Get push origin master, the branch you want to push. And I'll show you what branches are in a sec. And now if you go inside of GitHub, refresh your page, you would now have the code and all of its versions on GitHub now. Notice that we
Okay,
don't have the password as well as the stuff in the ignore.
I was just going to ask, I have the password.txt showing up in mine.
Oh, that might be because it might not fully be in the ignore.
Looks the same.
Files in my directory, even though I pushed. So I did git push origin master. Nothing is showing up.
Did you refresh?
Let me see. Okay. Nope, still nothing in there.
Inside of your terminal, did it say you can't push because there's new changes or anything like that?
It did say earlier when I did git push origin and I typed in a URL, it said failed to push some refs to, and then it did the URL.
I think that might be because there might be something you would grab. So for you, go ahead and type in this command.
Thank you.
Git pull origin master.
Okay.
And then do the git push again. So what pull does is it pulls anything inside of GitHub here and pulls it down to your local machine. And that way they're both should be matching. So there might be a conflict.
It's asking for yes, no, or the fingerprint.
Should be the fingerprint.
Okay, should I just type in fingerprint?
I'm not sure.
Mine did that, and I typed in yes, and then it just said GitHub will be on your list permanent.
Oh
list.
yeah, that's what it is. Yeah,
Mine did the same thing, and then I checked the repository and it's there. So
yeah, so do yes after that.
Okay, I did yes, and then what am I pushing?
It should be whatever you just typed in.
Okay, so what should I push? So what is the command?
Git push origin master.
Okay. Do I need to do any URLs?
Nope.
Okay. Thank you.
So every time you would push, it would be this exact same command.
Okay, so it gave me an error again. Failed to push some refs to, and it rejected my master to master fetch first.
Interesting. Yeah, we might have to take a look at that during the break then. Yeah, there might be something else conflicting. Okay. So it should be on GitHub. If it's not, that's okay. And also, if you see your passwords on here, that might be because your Gitignore might not include it fully. So there might be a typo somewhere in your Gitignore. There.
But sorry about that. It's okay if you click on it and it actually says like password.txt. You just don't want it to have the actual password.
Correct. Yep.
Okay.
Yeah.
So it'll tell you what's in the file, just not
the file itself.
Right. Okay.
So yeah, let me show you around GitHub because for those that are relatively new here. So with GitHub, so these are the individual files that you have. There's the timestamp of how long your last commit was, and you can see each of the commits and what's been changed. So red means that it's deleted, and green means that it's added. So that's what the red and green means. The other thing is that you can see if you click on the file itself, that's what it is on GitHub at that specific time. So this is the most up-to-date code as of now.
Can you go back to that page?
Yes.
What does the raw, blame, and history mean?
Oh, that's an excellent question. So you want to edit your stuff, that's the pencil, delete the file, you can do it like that. So with the raw, you can actually view this in a raw format, which is just like a text format.
Okay.
And then history will show you the different commits that happen through it. And then blame is actually, it shows you who did each line of the code.
Okay.
So get
on the, on the history, does that mean you can go like open old versions?
Or are those through get? You can look at it, like right here, when we created files, you can look at what I did at that certain time. But if you actually want to go back to a previous commit, then you have to do it through get, not through GitHub. So yeah, you can look through time essentially with this.
Can you download them from here, or like you?
Yep. So if you go to the main page, there's a few ways you can download the whole entire folder. And this is what we'll be doing when we grade your assignments. We would actually be downloading it. So you can click here to download the zip, or you can actually copy the SSH here. So copy the SSH, and don't press enter. I'll just show you on my screen. You will do a get clone, and then paste it's SSH that we just copied. So what that does is that it will actually clone this whole entire folder, as well as all of the versions that you saved inside of a folder that you specified here. So when you actually are doing this, be sure that you don't have it inside of another repo, and you don't have a folder for that file too.
Wait, when you clone it, does it clone it in the directory that you're currently in, or did you just specify it in GitHub?
It will clone it directly where you have it here. So in this case, it will be inside of Git practice, but we shouldn't do it here.
Gotcha.
A better place would be the desktop or the your project directory. And you don't need to create a folder for this. This actually also creates the initial folder as well too. So it will also give you the Git practice folder on top of that. So you don't need to do make dir and then clone inside of that. So you can just do get clone, and it handles all that for you. So that's the few ways you can copy your, you can download your code and all your different code versions. The other way is that if you are looking at other people's code, let's look at someone else's code. I can look at, he's an old student from the previous cohort. If I look at one of his earlier projects and I want to download that project, or I want to clone it, you can do the exact same thing. Like you can clone it here, or you can download zip. If you want to copy this project inside of your own GitHub, it will actually be called forking. So forking will bring this whole GitHub project inside of your own account. It will still say that it's from the author, but then it would be a copy of that inside of your own account. So you can technically fork it as well. This tab here is shows you all the different commits that you would be doing. It's from older to latest. So this is the latest one here, and you can see what you did and what other people did during that commit. This one talks about branches, and I'll show you all the branches and what branches are in a bit. And these next two, those are technically for other types of projects. Like if you're creating a Ruby gem or a JavaScript package, you actually need one of these packages or a release, for example. So you technically don't need these two tabs here if you're not making gems or those projects like those. So here is the contributor. You can see who worked on what and how many lines of code and all of that here. And I believe somewhere in here, you can see more statistics about that. So yeah, not really much here. You can see all the commits done and all that. So you can see all the different statistics inside of the Insight tab here. Okay, but again, you mostly have to look at the file itself and then the commit here. Issues is when you're dealing with bigger projects and you have certain bugs that people find and you have to resolve. Those are the issues. Pull requests is when you're working with other people. That is when they want to, what's the best word to do this with? That's if they want to request a change to be put inside of the main working branch, the main working code. So pull requests are where other people can add on into your items, into your code itself. You don't have to worry about actions because that's really depending on if you're doing gems and Ruby libraries and other libraries. Projects is a management system where you can create a project and you're able to drag and drop some cards and lists. This is for documentation. So if you are building a cool website or a library, you can have some documentation. These are security vulnerabilities that will show up in this particular tab. So if you have stuff out today, it will show here. The insights we already have been through, and then let's go into the settings. So with the settings, you can rename it. Again, you can only rename things that you don't have yet. And also at the very bottom, it's the danger zone, right? So this is where if you do want to transfer your ownership, make it public or private, archiving the repo, which means that you're technically tucking away, but you can't no longer push to GitHub and stuff like that. Or you can delete a repo. And that's the danger zone. So be sure when you reach this area, you absolutely are certain that you want to do that. And
You go back and forth between public and private if you need to.
Yes. It may ask for your password and other things.
Okay.
Yep. But just note that if it's public, everyone can see it. And if it's private, only you choose who to see it. So. And the other places is that if you go inside of your, I believe is manage access. If you go to manage access, this is where you can invite collaborators. So if you want other people to work on the project with you, then this is where you would invite them by either username or password. I mean, not username or email. And that's how you would do that here. And what they would do is that it will show up here in the bell icon, or it will show up in their email that they want to invite you, and they have to accept that invitation. So this is where you would add collaborators. And we'll go into how the flow is different with that, because it is a little bit different there. Okay, so that's pretty much the down and dirty of pushing things into GitHub. And the quick and flow of GitHub itself. So other things that is different that you should be aware about is actually not on this particular page. If you actually go here and go inside of your profile, go ahead and click your profile. This is what you should be working on in the next couple of weeks, is to really amp up your profile. Again, I would suggest putting a bio and a picture and all that information that you want, but essentially all of your repositories will populate here, right? And all of these little dots here, those are your different commits and contributions that you will be doing. So essentially, if you have your GitHub link inside of your resume, this is what will be showing up, right? This profile of your GitHub. And it shows you how active you are on GitHub. And also shows like what projects that you worked on, who you work with, and things like that. So they may even look at some of these projects and see what you did in those projects too. So this is a great resource for employers to look at when they're checking out how you work and how you code and all that there. And here inside of this particular box, that is where their eyes first is drawn in, is how actively you code. And the darker it is, the more often, the more commits you do in a day. Even though some of these are like light green, they're still like, that's 6 contributions compared to 1, which is the same color, which is super weird for me. But for you, it should be more colorful as it comes on by. And they can track it throughout the years as well. As you can see here, when I went through the cohort around 2015 and 16, that's when I did the most code here. So yours will look like this in the next couple of weeks. So I would try to get this box here as many green squares as possible, right? And the darker it is, the better it is. And don't just do commits for the heck of it. Just don't like every single line of code like puts hello, and then you do add and commit just to get a green box. You know, that works, but it's not really It's not really good. It doesn't look good here because you can actually see what contributions they are. So make sure that you're doing really good frequent commits and meaningful code. Like you're actually at a good stopping point for you to actually push up code, not just having it just for the green boxes there. So yeah, so make sure that you work on this page yourself. And again, this does take time as you're coming along. Okay, and also be sure that when you are having your contribution shown, make sure you also show your private contribution. This only shows the green squares of the contributions, but it actually doesn't show what you worked on privately itself. So that's just a statistical thing there. So that's the profile page. The other thing here is that you would have followers and following. So before we go on break, let's go ahead and type in your GitHub name inside of Slack, and let's go ahead and follow and each other on GitHub. So this one is mine. Go ahead and paste yours inside of GitHub, and then go begin to follow and unfollow. Well, don't unfollow, I mean follow and have those people followed there. So to be able to look for people, let me show you how this works. Oh, technically, let's say that I don't see Brendan here. So if I type in Brendan here at the search bar, you can search anyone inside of GitHub, right? And make sure you do all of GitHub. It might just be like in your repo or something. And then you go into users. That's where you want to be. And I think it's this one for Brendan. Is that correct?
Yeah, that's me. I haven't put a picture on there yet.
Who's Churcher? Someone took your name and put ER at the end.
Probably losers.
So yeah, that's what all you have to do with your classmates. It's just to press the follow button there. So I'll give you some time during the break to do that. So that's what you'll be doing when you're following and unfollowing. And the benefit of that is that you can actually see what they've been working on in the feed, right? So you can look at all of the people that you follow, and then you can take a look at what they worked on. I'll go to a previous student, such as Carson here, and you can see what they worked on throughout the cohort. And you can look at individual commits and all the files, things like that. And also, if you're able to follow your classmates, it's actually easier for you to add a collaborator. Because when you're adding a collaborator, if they're not on your followers list, it will give you a whole bunch of people with the exact same name for some of them. While everyone's doing that still, there are some repositories. Like if we go back to the one that we were doing, you're able to star that repository here. So what starring means is that it's considered like a favorite. The more stars you have, the more people that favorite it. It's just like a liking system in GitHub. That's what the star means. Watch means, so if you click on this, you can say not watch, watching, release only. You can have your notifications be set to one of these settings here, right? So if there is a new commit or if there is a new change with it, then you can get notified either by email or the notifications here. And depending on which repo you're working with, I would have it not watching since you're practicing, but watching on those big projects like your hackathon projects, things like that. Awesome. So before we go to break, I actually want to show you one more thing just so we get this down. So let's say that we want to add additional code, right? Instead of, I'm gonna add a whole new line here inside of my menu. I'm gonna say main menu. And with this, let's actually use some Ruby gems since we haven't used that in a while. So I'm actually going to go inside of here, inside of my my get practice directory, and I'm going to create a gem file. And does anyone remember the command to create a gem file?
Bundle init. Bundle.
Init, yeah, bundle init, yeah.
Bundle init. Go ahead and run a bundle init inside of your get practice there. So that will give us a gem file. And let's go ahead and add in the colorized gem. So it'll be colorized. So this is inside of your gem file. You would add the colorized gem. And what steps do we need to do afterwards? So after we add the gem into the gem file, there's one more step we need to do.
We have to reference it in the main RB, or right?
Before that, actually.
Oh.
Something having to do with our terminal.
It's a gem install and then the gem.
Yeah, we will actually just bundle everything together. So you can do gem install, or since we put everything inside of the gem file, we can just do a bundle install or just a bundle. Nice. So go ahead and run a bundle inside of your project directory. I just paste the same thing twice. Awesome. So now if we go inside of our main RB, this is where we would reference the gem up top. So we will do require colorize, and then we're able to use this depending on whatever the documentation is. And for this particular one, this particular gem, we just do the dot colorize on a string, and then we can specify what color we want it. In this case, I'm going to do cyan. Sure. I'm actually going to have this here, but for the exit, I'm going to do red. So let's go ahead and save that. And I'll slack out my main.rb. I just changed some of the colors with colorize and with the strings. I'm just simulating one of the changes, right? So then if we go here and test out our code, so we go Ruby main.rb, and it does change colors, and that's what we want. So test as you go. So at this point, I want to have this up and running. I want this inside of our Get hub, because right now it's not saved inside of our local machine yet. So if that's the case, we'll go through the flow, and the flow that I'm referring to is this one here of continue changes. Continue changes. So when you're at a specific spot where you want to update your GitHub, make sure that you save all your files, test that it works, and then run these specific commands there. So it'll just be get add, which tracks all the files, and then get a commit. This will label it. I say add colorized gem. And then the last part is to push this up into GitHub. Get push origin master. So again, origin, what origin is that specific GitHub remote, and master is a branch. And we'll get into branches once after break. So now that you did that, go ahead and refresh your code. You should have a gem file here, and your code also is updated to what you just did.
Can you go back to the terminal so I can see what you did after you did commit?
What you put master or something?
Give me 1 sec. There we go.
Okay, git push origin master.
Yep.
Okay.
Okay. There's one more thing I want to teach you. So let's say that I messed up on a commit. I'll simulate this so you don't have to do this. Just follow along with this next part here. So let's say that I actually want to change this to black, right? Because I think black looks cool. If I did an add and commit here, so get add here, but I don't want to commit it yet because as I test this out, if I do Ruby main.rb, I can see it's black on black, and that's not a good thing to have. So if I actually change my mind, but I already did a get add, there's a way that you can undo that, right? So even though that you did a get add at this point, you're still able to undo at this specific place. The easiest thing is you can undo what you did here and then add that changes, which works as well. Or you can do this command here. So if you go inside of here and you're at that specific directory, it would be like this. Hold on, give me 1 sec. There we go. I would do get reset. And I actually want to go to the most up to date, which is head. That's the head, which means the most up to date, and the main.rb. So as you can see here, that won't considered to be a change after we do get status. Even though it says it's already inside of your code. So we might need to do one more step. So we need to go inside of that file. So we will do get checkout main.rb. So now it's back to the original color that is in black. So if you already added, but you haven't committed yet, you're able to undo your changes. If it's a lot of changes, what you would do is you would do get reset head main.rb. Again, what this does is that it will actually take the most up-to-date code from GitHub, which is this particular version here, and change that to the main.rb. And then what you would do afterwards is you would go into that new version of that code here. And it will take you back in time to that particular area. So that's one way you can go back in time inside of your code. The other way you can do that is, I believe in here in Subhead, you can go back in time to a specific commit ID number. As you remember, we can grab the ID number, I think in here too. Yeah, so with this specific ID number, you can just copy that and put that in here in Subhead, and that will go into a specific commit version of your code there. So that's ways you can go back in time throughout your code. But in most cases, just be very careful and cautious of what you're doing. And then just continue working like normal and save your file and push it up into your GitHub as often as possible. So before
what does the checkout function commit or line actually do? Does it open it in VS Code or like how do you use that?
So checkout works with branches as well as other versions of your code. So we can check out to this up-to-date branch here with the checkout command, and we'll go more into that after break.
But I guess I'm wondering what it actually does if you run it. Like,
it takes you back in time like this.
So it actually alters the file, or
it will take you to another version of it. Not really.
Okay.
Yep.
I see. Okay.
Yep. So the main thing is that you make sure you get the flow down. That's the most important thing and takeaway. And we'll have practice with this, and you'll also be doing this inside of your projects and everything. So the
Hey,
very
Henry.
beginning
Oh.
thing, yeah.
How do we access the DPL sheets?
Oh, it should be
What
pinned.
part of the? Oh,
So if you go inside of your Slack,
Jake, I just slacked you the link.
pin
okay,
items.
cool.
Yeah, it's also here too.
Okay, sweet. There it is.
And I would bookmark it.
Okay.
Can you put that on the general or our class thread?
Yep, that's in the class pinned items there. So again, you just go to the thumbtack, and then it's this last item here.
Yeah, I put it there as well. So
Yeah.
Cool.
Yeah, but that's where you would find it. It's in the pinned items, because later on, it will delete the messages because we're the version that we're using in Slack. So the pinned version is where you'll always find it here. What is this one? Oh, okay. Never mind. So the one you will be looking at in the DPL sheets is the get flows. And I'll talk about references a little bit later on. So the get flow is initially when you push, you'll do get init, and you only need to do this once per project at the very beginning. And then you'll do get add and commit at every single point of where you are updating your code and saving that information. After you add and commit, you will then do, again, you only need to do this once per project, once per repository. You need to connect your local repository here to your GitHub repository here. So you would go into GitHub, create a new repository, and connect those two repositories there, and push up your information there. For continued changes, you can do add and commit, and then you would push it up like that. Okay. So when we come back from break, I'll show you the collab flow, which is on this side, and how you can work with other people, and a little bit of some get references as well. Some of them that you already know is the status command and also the log commands. So you can play around with those commands. And also you can take a look at differences between files. And then Vim, when we were in Vim, this is what you type to go into insert mode, and this is how you escape from it. So be sure you're using the sheet beginning when you're working on this Git here. So any questions about the flow of things? You would essentially be doing this multiple times, the continued flow over and over again.
Do you always want to have a git ignore in each project?
Yeah, that's nice to have. Even
So like
though if you don't use it, it's good to have there just in case.
So like if we were gonna put like our grocery store on here, we would have to do the get or the touch.get ignore, and then the get init, and then do the add and all of that, and create the repository and everything.
Yep.
Okay.
And then I'm planning to have a little bit of time, and we can practice that so you can push your about me to GitHub later on. Okay, any other questions? Okay, let's go ahead and go into our final break. Come back at 8:10. So let's jump back into it. So now I am going to talk about what you would do when you're working with other people. It's a little bit of a different flow. But first, I actually want to talk about the branching and a little bit of what branching is and all that. So with branching, essentially there are different versions of your project files, right? They're just alternate versions of your project files. And when you are branching into other branches, you're each labeling those branches whatever it is you want to call those different versions. Like you might have a branch that is called like styles branch if you want a style, or a branch for coloring, things like that. But there is one main branch that you would be able to be encountered, and it does come straight out of the box, and that is this master branch here. And this master branch is essentially the most up-to-date working version of your code. So you can check your branches. If you do get branch inside of your terminal, you can see that you already have a master branch here, right? That is essentially your main branch right there. Again, everything inside of master should be your most up-to-date working code. So essentially how branches work, it really correlates to what I have inside of my profile pic here, which is essentially is like dealing with time, right? So if we have our timeline here of our code and when we did do our commits and all those, right? This is our timeline here. This is all of our commits. And by default, this branch here is the master branch, right? This line and all of the commits is its own master branch. After that, if we want to do a different type of branch, what it will do is that this portion here, which is considered to be the head, which is the most up-to-date at a specific time, that is called the head there. So let me label that there. So the most up-to-date on GitHub, as well as Git, is called the head of the branch, right? Because it's the head of the master branch. So when we are doing alternate branches, think about it like time, like alternate timelines. Hopefully I draw this okay. So it will be like this. You have a branch like this, or another one down here. You can have multiple branches going off of the head here. So it's whatever you did up to this point, and towards the past there. So with that, you can then do your own commits inside of these other branches, inside of these alternate timelines. So typically you would name these branches what feature you're working with, or the branch your name if you are working with other people. So you can typically have multiple branches together correlating when you're coding at the same time. One thing that you would do is that when you are coding in different branches, you shouldn't be working on the same file or the same thing. Because if you all are let me do this here. If you all are working inside of like the main RB, there will be some conflicts. And I'll show you how to resolve those conflicts, but we want to avoid conflicts as much as possible, right? So when you are dealing with other branches, make sure that you're working in other files and other features that doesn't correspond with what other people are dealing with, or else you'll have some conflicts. So when you are dealing with branches, I'll move it over here. When you're at a good point, this is where you would combine what you have into what the main master branch is, so other people can see it. So these branches, you can see it, and also if you push it up to GitHub, GitHub can see it as well. So let's say that we each have a branch. I'll have one for Henry, and Harlan has his own branch, right? We're all coding in different files and different pieces of the code, right? So if it's time for us to all put our code all together, this is the process that we're doing. And this is kind of the visualization that we're technically doing. Can I move things? Huh. So essentially, if you want to merge what I have, again, you have to test it out, make sure it's up and running, to the master branch, which is the most up-to-date code. I need to do it one at a time. If we both push at the same time, there will be a conflict. Again, we want to avoid conflicts as much as possible. So just go one at a time. I'll go first. So what you would do is that you would do either a pull request or a fetch and rebase, and you would actually see if you're able to combine your timeline to the main timeline here. If you're able to, then great. You can actually have that to be in correspondence with the master branch. But if you can't, that means you have to fix the conflicts And also you need to resolve this so you're able to. So that's the process you have to do, is to make sure if you are trying to combine your branch into the master branch together, you have to make sure that there isn't any conflicts and it's a clean merge. So that's what we're technically doing. We're actually merging two branches into one, right? That's called merging. So I'm merging my branch into the master branch. And then now this is considered head. So what I did at the very top part here, that now will be the head of the branch, the tip of the branch, right? So that's what you'll be doing one at a time. And then it's Harlan's turn. He has to do the same exact thing. He would have to pull my latest changes because the master branch is no longer up to here, right? It's actually up to here. So he needs to pull the most up-to-date change and see if there's any conflicts. If there are, resolve them. But if there aren't, then he's able to combine both his branch and my branch together. I'm gonna make this smaller. Yeah. Just pretend there's little circles and they're all perfect, even though they're not perfect. There. So that's Harlan's stuff here.
So technically in this model, you can't both work simultaneously, right? Because like if you were and merged changes, then they wouldn't be in Harlan's branch. Like they'd be reverted back. So you really have to do it like someone makes changes, pull it. Someone makes changes, pull it.
Exactly. So you have to make sure that your code is most up to date with masters, and then push it up as frequently as well. That's a good point.
Okay.
So now, once you have everyone's code up and running, this is now considered the master branch, right? So then, again, if I want to work on something else, then I would create another branch from the head branch and continue on from there, right? So that's kind of the visualization of the process we'll be doing. The actual thing that we will be doing, I'll actually show you inside of the terminal. But that's the general idea using my ugly circles and lines here. So any questions about that idea?
So just for understanding, I mean, you have to be, so communication and things like that, like when you're working on a project with multiple people, like you have to be really clear about those different sections. So it almost probably takes a little bit of practice, like get good at doing this so you don't have to resolve as many conflicts, huh?
Exactly. Yeah. Communication is key when you are collaborating and coding. Because I have had students in the past, they worked on the exact same feature, the exact same file, and like they have a whole bunch of conflicts because they've been doing the exact same thing, right? So good communication is key, just so you can have an efficient workflow. And if you do have to work in the same file, because occasionally that does happen, just make sure you know and communicate to your partner of what to keep and what you can take away, or else you would actually overwrite their code on top of your code. And you don't want that. Like, for example, in this diagram, if Harlan didn't communicate well with me, he would actually have his little circle. I'll do this another color. His little commit. Can't change colors here. Okay. Pretend this is another color. So it will take over into his version instead of mine, instead of combining them both. So we actually don't want to overwrite each other's code. We actually want to collaborate and combine both of them together. So that's the general goal when you're collaborating too.
So would best practice be whenever you create a new branch, really just create another page and then just have someone just require that on the main RB? Or request those pages?
Yeah, that's one way you can look at it. Or if you are working in another function inside of there, make sure that you're each doing your own function or methods.
So what if I was making a method on line 27 and someone else was making a method on line 27? Would it overwrite that line, or does it not matter the line number?
Let's talk about that next, because if you just merge it directly, then yeah, it will be overwritten. Like the last person that merges it that's a new up-to-date code. But if there are some stuff in there that both of you want, then there's a certain way you have to merge it. And I'll show you how to resolve conflicts. any other questions before we actually code this out?
So long story short, just kind of Reader's Digest, essentially you make the master to work on it, and then you create branches to protect the core code, and then you upload it as you go instead of altering the main code.
Yep, that's exactly what is the main plot for this movie, right? Is like don't mess with the main timeline, right? So consider the master branch, the main timeline, and the alternate branches is what you want the ideal timeline to be. So anytime that you're thinking about Git, just think of Back to the Future and how you shouldn't ever mess with the master branch when you are coding. Okay, let's actually play around with this concept, but in actual command line way. Cool. So if you want to see all your branches, it's just the keyword get branch. By default, there's already a master branch for you. Again, that's the main timeline. And if you want to create other branches, there's a few ways you can do that. The first way is you can do get branch dash get branch and then the name of the branch. So get branch and the name of the branch. That will create it for you if you want it to as well. But the thing about that command is that when you do it like this, like if I have like a foo command, it will create it for you, but you don't actually are navigated into that branch. So a better practice to do is instead of doing get branch, you actually do a get checkout -b, which stands for branch, and then the name of the feature or your name or whatever branch name you want to call it. I'm just saying foo just for testing purposes. So what this does, it actually does two steps into one. It will create a branch with this part named foo, and then checkout will get you into that branch. So how you navigate in between branches is what this checkout command. So now if you do a get branch here, it's highlighted in the foo branch. That's what branch you should be in. And then to navigate back into master, you would just do get checkout and then whatever branch you want to navigate to. So now I'm in the master branch, and for a sanity check, I can do get branch, and it says that I'm right there. So that's how you create branches and navigate in between branches. Let me slack out these commands. I don't know what I did. I pressed a weird command in my my bar, my touchscreen bar, and I don't know what that did. So that is the get checkout command, is how to navigate in between it, and get checkout -b is how to create a branch. So for this example, whatever you're doing inside of your foo branch, oh sorry, I'm not in the foo branch. So we do get checkout to foo. Whatever you're doing in the foo branch doesn't affect the main branch here of the master branch. So you can do whatever you want inside of it. It doesn't affect it in any way. As soon as you switch branches into the master branch, it will grab everything from the head into the master branch there. So that's how you would navigate in between branches and how to create them. So if you want to delete a branch, because this is just for organizational sake, I would still keep them for just in case, but then delete them afterwards. If you want to delete a branch, you can't be in a branch that you want to delete. The other thing is, don't ever delete the master branch, because again, that's where your most of the day up to running code is in the master branch. So if you want to delete this branch, you would do get checkout in out of the branch you want to delete. So in this case, I'm gonna go inside of master. We're now in the master branch. And to delete it is get checkout -d and then the name of the branch. Did anyone else get this as well?
Does it have to be lowercase d?
It's not checkout, it's get branch. So to delete a branch is get branch, not checkout. There we go. So if you want to delete a branch, make sure that you're not in the branch that you're deleting. And also, that's the command for that. That will also delete all of the commits you made in that branch, and also any changes you did inside of that timeline, right? So be sure you want to do that. Unless you have it up to date inside of your GitHub, then there's no way to get that back. So now let's go ahead and create another branch, and we'll use the checkout command. So I'm just gonna say my feature.
Hey, Henry, it's not letting me delete branch foo even though I switched to a new branch. Why is that?
I'm not sure. We might have to double check on that. So let's go into another branch. You're still able to go to another branch. So we'll do get checkout-b. Again, this goes and creates a my feature branch, and then it will navigate into that branch. So for this next part, I'm going to try to show you a few things, and hopefully I'll show you what a conflict looks like, but I don't think I can replicate a conflict, but you'll always encounter conflicts. So let me try to do a conflict. So let's say that inside of my code, I'm changing along stuff, right? Sometimes Git will pick it up as a conflict or a change. Sometimes it doesn't. So you need to be sure that you know what you're doing here. Get enter Kate, enter here. So I'm just gonna change it up a bit, and let's see what else. I'm gonna do that. Sure. I'm gonna try to simulate a conflict here, because technically this will look different than the head. So what you would do, and there's multiple ways to do this. Let me show you actually the best way of how you should approach combining both your code from your branch into the master branch. So again, you should test it out, everything like that. You would then go ahead and go add and commit, just like normal. You would do a get add and get commit. I'll just say changes. So when you add and commit, that will add and commit inside of your branch that you're currently on. And be sure that you're on your own branch. If you're not on your own branch, switch to your own branch. And here, typically, I would do a get push origin master, right? But let me tell you a thing about this command. What this means is that I am pushing to GitHub the master branch. Well, currently, I'm not in my master branch. The changes that I just created is in my feature branch, right? So if you want to push into the my feature branch and have that branch be onto GitHub, then it would be here, instead of get push origin master, it'll be get push my feature, the branch name, or whatever branch name that you're using. So what this does is that it won't create, that's fine that it says this. It won't create a conflict with the master branch because you're just pushing this branch onto GitHub. Your changes there. So you can view those changes inside of here. So now you can take a look at branches. So you can look at branches here inside of this little tab, or you can take a look at branches here, and there's multiple branches. Just note that if you are deleting it here, it only deletes it from GitHub, not from your local machine, and vice versa. If you do delete a branch inside of your local machine, it doesn't delete it onto GitHub. So if you do delete it, you have to do it in both, if that makes sense. So this is what I did in the my feature branches. I made some changes. I changed it to red, things like that. So I actually would pull in the latest code if I want to continue to make more changes, right? And typically, I don't know if this will work. I'm gonna try to do this on GitHub and try to do a conflict.
Hey, Henry.
Yeah.
If you make an edit in GitHub, does it affect your file on your computer?
Not
Or no,
yet.
no, not yet.
Yeah, because when you're doing on GitHub, it's still technically on GitHub. If you want
Okay.
those changes to be reflected, this is the next step you would do. So it's actually a two-step process. So first, go ahead and go into your master branch. So what you want to do is that you want your local master branch. Technically, you have two master branch, one on your GitHub and one on your local machine. You want your local master branch to be the same as your one on to your GitHub. So we'll do a get checkout master. We're now in the master branch. And you can do this two ways. You can do the fetch and rebase way, or you can do a get pull and merge. But never do both, like flip flop between the two. So I'm going to do fetch and rebase. So get fetch, and then you can specify where you are wanting to fetch it. What this command does is that it brings the code from GitHub here inside of the master branch down to your local machine. That's what the fetch origin master does. This next part is when we do a get rebase origin / master. What this line does is it will try to combine what GitHub has and what you have on your local machine as best as possible. And if there are conflicts, it will tell you those conflicts. Hopefully we get a conflict, so I show you what that looks like. And how to, yeah.
When you do this rebase, does GitHub ever overwrite files if they match or if they clash?
Maybe. If there's a close enough change, it might override it.
Okay.
But if it's totally different change, then it might handle it as a conflict.
Does that mean that sometimes it can have two matching files, for example, version 1 and version 2, that it forgot to overwrite? Two files?
Yep, most likely.
Thank you.
So for this particular case, looks like the changes I made isn't as drastic enough, so GitHub didn't pick that up as a conflict, which sucks. And then you would do this again inside of your own branch. Yeah, even though I changed this here, it still didn't pick it up as a change. That sucks. So now if we check out into my feature branch, I said check instead of check out. That's my bad. We would run that line again. We would do get fetch and rebase. So you do get fetch origin master, and then a get rebase origin / master. Oh, yes. Wait, yes. I got a conflict here. So here you can see what a conflict is. So when I did a rebase inside of my own branch, since there's two different files that I worked on, one would be the one on GitHub and one would be on the one that I have inside of my local machine. They are actually two different changes. So that's why it's conflicting here. So this is what a conflict will do. Sometimes it'll auto merge it. So like the other changes that we have, like inside of the gem lock and stuff, that will auto merge. But for specific conflicts of what it can't auto merge, it'll come up like this. This is actually the first time this happened in like 6 to 8 cohorts. So I'm very excited if you can't tell.
Congratulations, Henry.
So with this conflict here, I'll show you how to resolve it. Because if you continue on, you'll always get this error and you actually are stuck in a rebase loop. You actually don't want that. You have to resolve this conflict, add, and then continue on with the rebasing because you're still in the rebase here. So with the conflict, it'll tell you what file the conflict it is in, and it is in the main.rb file. And you can see there's a little C here for conflict. And these are what conflicts will look like. So typically, you'll actually encounter this sometime in your development career, is that you'll have some conflicting code. This is where the communication happens. So this is what is your change that you have versus the one in a GitHub, right? This is what GitHub has. or wait, hold on. Let me take a look at this for a sec. I think I changed it to red and green, right? Yeah, so this is what you have and this is what GitHub has. So you need to communicate of what you want to have inside of this particular conflict. So whoever worked on this, if you don't know, you can do like a get blame. And I don't know how this command works. I think you can do get blame.rb, main.rb, and it shows you all of the times and all the commits that a single author has. So you can take a look at who worked on it, what time, things like that. So that's what the get blame command. And it's a long list. If it's still running, you can just press Q and that will take you out of the list. So with this particular case, you need to communicate to whoever is the author and see which one you want, which version you want. Do you want the top one or the bottom one? Or if you want both, and then change them slightly. So for VS Code, it's actually very easy to do this. You can just press these buttons, and it will either accept the current change or accept the incoming change or accept both, right? That's pretty easy. But in other text editors and other languages, you had to decide between the two, and you had to delete these syntax. Just delete them entirely, or else it will think that is a conflict.
So what does accept both do? Would it keep all the lines, and then you'd have like duplicates when you run it?
Yes. So when I say keep both, it will have both of those changes. And if you do keep both, you might have to change it to maybe your use case. So in my case, okay, I did. So in my case, let's say that I want these different colors, but I also want mine to say main menu like that. So let's say if this is that particular case, I actually do want to keep both. I'm just going to change it to my use case. So this is going to be red, and that one's going to be green, and this one will say my main menu now. So technically, that's combining both and coming to a compromise with those two changes there. So that's where the communication comes in. And you would continue doing that in all of your conflicts.
But right now, you're just changing your branch still.
Yes. So you would continue fixing that and see if there's any conflicts with your branch and master branch. And that's what this will say. Luckily for us, there's only one here. And once you did, what you would do is that there's a specific flow you have to do. So first, save it, test it out, make sure that it is what you want it to be. Then you would do a get add, and you're very tempted to do a get commit, but don't do a get commit here, because that will take you into the rebase loop. You actually will be wanting to do a get rebase -- continue. What this will do is it will continue to combine both of your code together, so it will be the most up-to-date code. So it's trying to combine both of them together. And if it continues to conflicting, just resolve those conflicts, add and continue the rebase, and it will be in those stages there. And once you're done, it will say apply, and then whatever your commit message is there. So that is what you would do when you want to combine both of your code together. Now the next step is that you want to push this into your own branch now. So get push origin my feature. Get push origin my feature. Again, this pushes some items into your own feature branch. And if you see this error here, that means that there is something inside of GitHub, this ketchup and mustard error. There's something inside of GitHub that is different than what is inside of your local machine. If that's the case, you would want to pull and see what those items are and try to resolve it. But I know that mine is the most up-to-date code. So what I'm going to do is I'm actually going to decide to push to another branch. So I'm going to grab everything I have, and I'm going to take it to another branch. So get checkout -b new branch. And now I'm going to push this into my new branch here. So get push origin new branch. One last step for this to be combined into master. Because technically you can push this into master, but I want to have an additional step just in case if you mess up. So now your branch here should be on GitHub. And that's one, my branch for my particular case is the one that's most up to date. So what you would do is you would want to create a pull request inside of GitHub. Because now that you update it inside of your repository, you want those changes to be reflected inside of your GitHub here. So if that's the case, then what you would do, you can do it here, or you can do it here inside of the pull request, new pull request. You can compare it to my branch. And you can see all the changes in between the branches, right? And create pull requests. So when you're working with other people, or maybe you have like a project lead or anything like that, you would then give this link to that other person, to your partners or to anyone else other than you. That way they can check your code, make sure that you're doing the right thing, and make sure nothing's conflicting. Because at this point, if everything goes well, this should be green. If this says conflict somewhere, that means that you forgot to do the previous step that we did here. Right? You didn't resolve any conflicts at this stage. So be sure that this is what you should be seeing. It shouldn't say conflict. If it does, you have to do this step again here. And then after that person is done, you would have to go ahead and confirm the merge. And that branch is now combined into master. So now your master branch is up to date with those new changes. So we combine both of the, I believe it's my branch, into the master branch now. And that's essentially how you would do it. And that's the process you would be doing over and over again. And your other teammates, in order for you to get these new changes, you would do the step that we did here. So you would go to my master branch. So you would go to get checkout master. And you would do get fetch origin master. Again, that grabs all the code from GitHub into your own local machine, and get rebase origin / master. This will try to combine it as best as possible. And if there's no conflicts, that's actually the goal. So this is how you get the most up-to-date code as well. So after everyone updates their code, this is the last fetch and rebasing here, or else you have to do it multiple times. Okay, that's a lot. So let me break that down inside of those sheets for you. So initially, when you're working with other people, one person just needs to create the project and to create the repository on GitHub. So that's the first thing you would do if you are working with someone, is to initially create the repo and then the project itself, right? And it doesn't have to be at a stopping point. You can just have like an empty folder or anything like that. The next thing you would do is that that one person, I'm just gonna call him the project lead for now. That one project lead person would then follow these steps. Follow these steps here of the initial commits. So that person will do init, add, commit, link it up to their GitHub, and then push it to master, what they have on master. So that one person is creating the project as well as the GitHub repo, and then following these steps here. Once that person is done doing that, they will then go into settings, go into manage access, and they're able to invite their collaborators. So you can search for people by their username or by their email, right? And make sure they're added. So the other people on the team, other than the main creator, they would accept that. That would be either in here or inside of your email. So they have to accept that invitation. Now, after they accepted the invitation, then you have access to this GitHub. Everyone else but the main project lead would then go into here, make sure that this is SSH, copy this SSH here, And then you will go into your directory, into your own coding directory, and do a get clone, and then paste that SSH. Get clone, paste that SSH. What that does is that will bring that person's code into your own machine for you to work on. And then you're able to go into your own branches and then code from there. So you're able to code after you go into your own branches. After, when you come into the flow of where you're about to combine all your code together, do it one at a time. It's a group effort, right? So make sure everyone's at a good stopping point and do this one at a time, walk it through it, everything like that. So first, add and commit. So save what you just did and make sure it's tracked, and test your code out too. And then that person, the next person that's getting their code up to date, they would need to get their code up to date in their local master first. So get fetch origin master and get rebase origin / master. That will try to get the most up-to-date code on GitHub into the local machine and see if there's any conflicts from there. So if there's conflicts, you would resolve those conflicts, right, with good communication and compromise, right? There's no one answer. It's just the right answer is what is the correct way of doing things, not who's right or wrong. It's more of how things should be done, right? After that, you would do a git add when all of the conflicts are resolved, get rebase -- continue. And you would continue doing this step until all the conflicts are resolved. And then you would push into the master, into your own branch name, and do a pull request. Once that pull request is done, what we just did here, then the next person will follow the exact same steps here over again. So you'll be doing this step over again for every single person to get their code up to the master branch and combine. Once everyone has been finished doing all of this and completing all the conflicts and all that, everyone will need to do these 2 lines of code once more. That way you'll get the most up-to-date code. And then there might be conflicts, there might not be. So there's the last fetching and rebasing there. So that's the flow of the collaboration. So it is a lot of steps, but just practice this and it will begin to make a lot more sense. And we'll walk through it here and there. There's other things that I didn't get into deep enough, and I want to show you what those things are. So again, if you want to know about the branching and other commands, go to get references in the DPL sheets. So these are the branching commands. That's how you can look at all the branches, to switch in between branches, to create a branch, and to go into a branch, and to delete a branch, right? Those are the branching commands you would use. These are the different remotes that you can look at. So you can look at all the remotes, you can add a remote, or you can remove a remote. We already talked about Vim. These are information ones, we already talked about them. Let's talk about the stashing and as well as the alternatives. So for stashing, what you would do is that, let's say that you are coding along and actually what you did it hasn't been working and there's a bunch of errors. You actually don't want your code. You actually just want the new up-to-date code, right? You don't want the code that you just did so far. One thing you would do is you would actually stash your code. So you would do a get stash that will put all of the untracked code into a pocket dimension. All right, that will put it inside of a stash item, so you don't have to work with that code. You can just get the most up-to-date code. Again, this only works for untracked stuff. So if you add and commit those changes, you can't really stash those changes. Those are only things that you can't add and commit yet. You can also list all the stash items. You can revert back to a stash item, or you can delete a stash item. So you can do those with stashing there. So that's to set aside code versions. Now here are some alternatives that you could be doing. So instead of doing a fetch and rebase, so the version I showed you was fetch and rebase. The other alternative is to do a get pull and merge. So it's almost the exact same thing of what it fetch and rebase does. It's just different commands to do them. So the Harlan likes to do pull and merge. I like to do fetch and rebase. So it's just depending on your type of style. There's subtle differences is between them. Okay, so for the last couple minutes, I actually want to follow this flow. Wait, not this flow. Follow this flow inside of your About Me and any other projects you want to put inside of GitHub. So let's run through this one more time. And we're not doing the collaborative flow. We'll do that tomorrow once we get into our groups. But for today, let's just try to do our own project and see how that process is like. So I am going to CD out of this project. And then if you have errors, go ahead and do a new tab instead. And I'll help you out with those errors after class. So go ahead and CD into your project directory. So CD into on my DPL summer. And I don't have a About Me. I'll push the Ruby Day 1 folder here. But you can push your About Me or whatever practice folder you want to push. Just don't push the, what is it called? Don't push the get practice because it already has a get hidden file there. So I'm going to CD into Ruby 1. You should CD into your Ruby 1 or whatever folder you want to push to GitHub. Could be your About Me as well. I don't know if I showed you this, but have I showed you that inside of your desktop, you can actually drag and drop stuff inside of your iTerm? So for example, if I drag Ruby 1 inside of my terminal, my iTerm, that didn't work. It'll actually CD already inside of Ruby 1. So that's another way you can CD into it. And also, if you drag that into VS Code, that will open it up inside of VS Code, that directory. So those are two hidden facts that you will find out about. Okay, so let me show you the first couple steps. So let's say I'm at a good stopping point. So first off, I need to get init inside of this new directory. This initialize the repository. Yes.
Henry, just for clarification, what we're trying to do is set up our About Me web page, right? So if it's in a different directory, like for me, the directory is About Me. That's the one I'll be working with, correct?
Yes. So anytime that I say Ruby 1, it would be your About Me or whatever folder you're working with.
Can you change directories? Like after you push something, what if you wanted to move the folder later? Does that affect anything?
If the ls-a, if this file is still in that folder, it should be fine.
Okay.
Yeah.
Gotcha.
Yeah, but if there's a folder inside of that file and you move it away, it won't actually track that. That's a good question. Okay. So let's do a get init, and then we'll do get add space dot. That will add everything that's untracked. Oh, sorry. Let me zoom in a bit. Sorry about that.
Henry, what's the command to go up in directories?
It's cd space dot dot.
Thank you. Okay. Thank you.
So we'll do get add space dot. That will add all the untracked files. And then I'll do a get commit -m. I'm just gonna say practice push. Sure. What prac? Is it just me or does that look weird? Is that how you spell practice?
Are you missing a C?
There's another C here. Whoa.
I can't spell, so I shouldn't be saying anything.
I don't know. We're starting to look.
Yeah, you got it right. You've been teaching for a while, Henry. I understand.
Oh man. Okay. I need to practice how to type. So we'll do get commit -m practice push here. It still looks wrong to me. And we are just labeling what we just did. And then the next item of business is if we go inside of your GitHub. So let me go inside of my GitHub. Let's create a new repository and have it named whatever project that you're trying to push up. It might be the About Me, or it might be Ruby 1, or whatever project you're practicing now. For me, it's Ruby Day 1, and I'll be more specific, Summer 20. You don't need the Summer 20. That's only for my account since I have multiple Day 1s. Everything would be by default. You don't need to check anything else. And then go ahead and create the repo. So after you create the repo, I would grab this SSH. Again, make sure SSH is toggled, and it should say get. It shouldn't look like a URL. That's not what we want. We want the SSH. The HTTPS, it will ask for a password every single time you push, you pull, you commit, all of that. So we actually don't want that. We want the SSH. So go ahead and copy that and do a get remote. Add the name of the remote. In this case, it's good to call the remote origin. You can call it something else, but it's good practice to call it origin and then paste it. Sorry, mine is a little bit out. There we go. So we're adding a remote here. And then finally, to get your code into GitHub, get push origin master like that. So with this is essentially how you would submit your assignments going forward. You're no longer zipping up your project. You're actually going to push it up to GitHub. And again, make sure you have the most up-to-date unbroken code here, right? And you would actually submit this URL up here. And make sure this URL leads to this page, the remote repositories page. So this all takes practice. This is a lot of steps. This is a lot of stuff to digest and how things are working. I would just know that there is certain steps you have to do. As long as you follow those steps, you should be good. And again, this does take practice to see how things work, to get the flow of things. And you're eventually will get faster and faster when you're adding and committing, right? So you'll find it to be a lot more faster, more efficient. So any questions about Git and GitHub? Nice. So yeah, tomorrow, Harlan and I and Nick will be watching you struggle when you're using GitHub tomorrow inside of your smaller group. So that would be fun tomorrow. But it's all part of the learning experience. You'll get a bunch of conflicts. You'll have a bunch of red things inside of your terminal. That's all part of the fun. So that's what is to expect for tomorrow. So if you have some time, in between your classes, or in between today's class and tomorrow's class, there is other lecture videos inside of Git that you could watch, and other files here that you can look at as well. So you can look at other things, tutorials and all that, just to brush up on Git itself. But again, the best thing to do is just practice. So I would just actually practice pushing everything we've done so far inside of GitHub. Like you could do Ruby Day 1, Ruby Day 2, even the SQL one, put that all onto GitHub. And make sure each of them are in their own repository. But yeah, besides that, I will see you all later, or tomorrow. Thank you.
Thanks, Henry.
Get it.
Thanks.
Thank you.